So on number 6, of course, I'm looking at what happens as x goes to plus or minus infinity. If I can do it all at once, that's awesome on my function. And since it's a rational polynomial, I really just have to look at the degree of the numerator, degree of the denominator. Oh, they're the same. So I'll use leading coefficient over leading coefficient. So I get 4 over 2, which is 2. Yay, y equals 2. Okay, next one. So now here's what I need to remember about sine. Ooh, if I look at the sine graph, that thing is non-stop action, right? Just keeps going forever and ever. It's like one of those kids that won't shut up in class. But I don't know any of them this year. So as x goes to infinity, this does not exist because all it does is oscillate. Crazy sine graph can't make up his mind. And then last but not least is sine of x over x. Now, if you remember back when we looked at limits before, we knew that if x goes to 0, this ratio equals 1. But now we're looking at what happens as x goes to infinity. So now, since I know x is not approaching 0 because I'm going to infinity, I could actually divide or multiply by 1 over x. So if I multiply by 1 over x, or divide by x, here's what happens. Well, I know that these two fractions are going to approach 0. It's going to keep getting smaller and smaller. Negative 1 divided by this ridiculously large number means everybody gets basically nothing, and positive 1, same thing. So sine of x over x has to be between 0 and 0, aka it has to be 0.